Hi, this is a screencast for Math 8, Lesson 9.3, Two-Way Tables. Our learning target is I can read and interpret two-way tables. Our vocabulary includes two-way table. We're going to talk about something called joint frequency, marginal frequency, and we're going to review the idea of percent. Please read pages 388 to 389, take notes in your comp book, and then do the online practice for 9.3. Okay, just really quickly a review of percent. A percent is a part of something divided by the whole. So if our whole thing is 10 and we take 7 out of those 10, if we put that in a calculator, 7 divided by 10, we would get 0.7. Okay, if we had another invisible 0 here and then move our decimal 2 places, we would get 70%. Okay? Okay, so if we had a pretend survey that has 2 questions, do you like skateboards, yes or no? Do you like snowmobiles, yes or no? We could put our results into our two-way table that looks like this. Here's all of our skateboard responses. Okay, so if you said, yes, you like skateboards, so we would have 80 people who like skateboards and also like snowmobiles, 45 people who like skateboards and do not like snowmobiles, so we would have a total of 125 people who like skateboards. If you said no, you do not like skateboards, we would have 25 plus 10, we would have 35. Okay, and if you said yes, you like snowmobiles, we would have an 80 plus 25, we would have a total of 105 people who like snowmobiles. And if you said no, that's 45 plus 10, that's 55 people who do not like snowmobiles. Okay, let me show you one more thing with this. If we take all of the people who like skateboards and all of the people who do not like skateboards, that's all the people who took the survey, right? You either like skateboards or you do not. So 125 plus 35 is 160. That should be the total number of people who took the survey. Okay, likewise over here, all the people who did like snowmobiles added to all the people who did not like snowmobiles would give the same number. Okay, 105 plus 55 is 160. And if we look at our table here, this is where all this data came from. So we have, here's 160 people took the survey. We can see the same numbers that are like the sums of these rows and columns. Okay, and so that's how a two-way table works. So here's another survey. Maybe this was given after a test. It's asking, did you pass the test, yes or no? Did you study for the test, yes or no? And this survey comes from our textbook, where there's actually a really good definition of what a two-way table is. A two-way table displays 2 different categories of data collected from the same source. So in this example, one category is what was the student grade, pass or fail. The other category was, did the student study or not study? And our joint frequencies are all of the numbers of all the responses divided into each category, so you can see how it breaks down. Okay, so joint frequency is a fancy term for all of the data that's in the main part of the two-way table. Marginal frequency is a fancy term for all of the data that's around the edge or the margin of the two-way table. So for example, if we look at the number of students who passed, we have 21 students who passed and studied, and 2 students who passed but did not study. That's a total of 23 students who passed. Okay, we have 1 student who failed and studied, plus 6 students who failed and did not study, so we have 7 students who failed. Okay, these are marginal frequencies. And over here, if we break it down this way, we would have 21 plus 1 is 22 students who studied, and we have 8 students who did not study. Okay, and then, so take a look at this. We have, okay, either you studied or you did not study. 22 plus 8 gives us a total of 30 students who were surveyed, and likewise, either students passed or they failed. 23 plus 7, there are a total of 30 students again who were surveyed. Okay, so this number represents the sum of either this column or this row, but it should be the same number. Okay, here's another example. You randomly survey students in the cafeteria about their plans to go to a football game and a school dance. Okay, so the question here is, how many students will attend the dance but not the football game? All right, let's take a look. How many students are attending the dance? So it looks like this row here is attending the dance, but not attending the football game would be this column. Okay, so to answer to that question would be 5 students will attend the dance, but not the football game. Okay, then find and interpret the marginal frequencies. Okay, I think we can do that kind of quickly. So 35 plus 5 means there are 40 people who said they are going to the dance. 16 plus 20, there are 36 people who said they're not going to the dance. And there are 35 plus 16, that's 51 people said they would go to the football game. And 5 plus 20, that's 25 people who are not going to the football game. If we look at the total down here, right, this is total. 51 plus 25 is 76. That means there were 76 people who took the survey. 40 plus 36, we get that same number. Okay. All right, this is a little bit more challenging sort of two-way table question, because what they're asking us to do is to take this data that is tallied on paper, right, old school, before Google Forms, and to convert that into a table like this. And when you get to the online practice, this table will be made for you, but you're going to have to read some tally marks and know where to put each sum of the tally marks. Okay, so let's take a look at how this works. So the question is, you randomly survey students between the ages of 12 and 17 about whether they ride the bus to school or do not ride the bus to school. So this page here, this is a yes, they ride the bus to school. This is a no, they do not ride the bus to school. And then on each page, it looks like the data is again divided by age, okay, on each page. Okay, so let's take a look here. This is the yes, they ride the bus to school, and here's the whole bus side here, and it looks like this row here is yes, they do ride the bus. So if we look at this, these numbers here, 5, 10, 15, 20, it's 24. That 24 would go into this cell in the table right here. So there's 24, 12 to 13-year-olds, that's 24 right there. Okay, 14 to 15-year-olds, that would be 5, 10, 12. There's the 12, 14 to 15-year-olds, 5, 10, 14. Okay, so there's the 16 to 17-year-olds. And then of all the students who said no, they do not ride the bus, we go to the breakdown. Here's 5, 10, 15, 16, that's there. 5, 10, 13 is there. 5, 10, 15, 20, 21. There's that 21. Okay, so then we could do our marginal frequencies, and all we're doing then is adding up the rows. These three numbers added together means that there were 50 students who do ride the bus. Okay, adding this row up, there are 50 students who do not ride the bus. If we add up these columns, the number of 12 to 13-year-olds would be total of, we had 40 12 to 13-year-olds. And we had 25 14 to 15-year-olds and 35 16 to 17-year-olds. So again, if we add 50 plus 50, we should have a total of 100 people who took this survey. 40 plus 25 plus 35 is also 100 people who took the survey. Okay, so there's some more questions that we need to ask with this. So, what percent of all students ride the bus? So remember again that percent is part divided by the whole. Okay, so we really need to look at the question. What percent of all students? So it's saying out of all students. Where do we find that number? Well, there was 100 people who took the survey, so I think that's the number it's talking about. Out of all 100 students who took the survey, how many were yes, they ride the bus? Okay, well, look over here on our marginal frequency. We have 50 people who ride the bus. So the part would be 50, the whole is 100. If we use our calculator, we'll get 0.50, move our decimal 2 places. That would be 50% of students ride the bus. Okay. All right, next question is, what percent of bus riders are 12 to 13? Okay, so again, we really need to look at the question, what is it asking? So it's asking, out of all the bus riders, okay, all the bus riders, how many are 12 to 13? Well, what's our whole? It's all the students who ride the bus. I think that's right here. There's 50 students who ride the bus. How many are 12 to 13, which is right here? So that would be, there are 24 12 to 13-year-olds out of all the bus riders. If we use our calculator again, we'll get 0.48 on the calculator. We move our decimal 2 places. That would be 48% of the bus riders are in that age category. Okay, we'll erase all this. Okay, last question here. What percent of 14 to 15-year-olds do not ride the bus? Okay, we really have to think about what the question is asking. So it's asking out of all the 14 to 15-year-olds. Okay, so that's the whole. Well, where do we find that number? Look in this column, 14 to 15-year-olds, there are 25 14 to 15-year-olds. So that goes into the whole part of our percent. And then it's saying what part of that whole do not ride the bus. Okay, so I think in our table, that's that number, 13 do not ride the bus. So our fraction is 13 out of 25. If we put that into a calculator, 13 divided by 25, we would get 0.52. Move our decimal over 2 places. That would be 52% of 14 to 15-year-olds do not ride the bus. Okay, so that's how two-way tables work. If you can go into the online practice 9.3 and get that done by Wednesday, that would be great. Thanks for listening, watching. See you later. Bye.